Hey guys, Mr. Backerberg here. In this video, we're going to look at solving equations that have variables on both sides. As we're looking at solving these more and more complicated looking equations, the steps that we're going to work through are as follows. Step number one is we're going to look for any distributive property that we can take care of and clean up. Once we've got that taken care of, if we have variables on both sides of our equation, we're going to try to get those onto the same side. Then, after that, we're going to check for any addition or subtraction that we're going to be able to get rid of. And then lastly, we're going to undo any multiplication or division happening to our variable within the problem. As we take a look at this first problem here, we're going to run through our steps. Step number one said that we're going to look for any distributive property that can be taken care of. There are no sets of parentheses in here, so there are no distributive property things that we need to do. So we're going to move on to step number two. Step number two said if there are variables on both sides, we're going to move things around to get all of the variables on the same side. So we've got two options. We can either deal with this negative 8x or we can deal with the 4x. I like to have positive variables, so in order to keep my variables positive, I'm going to look at getting rid of this minus 8x. And in order to get rid of subtraction, in order to get rid of this minus 8x, we're going to have to add 8x to both sides. Now when I add it to the right-hand side, I want to make sure that I add it to the like terms, so I want to add it to the 4x. So on the left-hand side, the minus 8x and the plus 8x will cancel each other out, leaving us with just that 7. On the right-hand side, if we take 4x plus 8x, that's going to be 12x, and then we still have that minus 17. Now, step number 3 said that we were going to look for any addition or subtraction to take care of. So on the far right-hand side, I see this minus 17. In order to get rid of a minus 17, we're going to add 17 to both sides. Now on the right hand side, the minus 17 and the plus 17 are canceling each other out. On the left hand side, if I take 7 plus 17, that's going to give me 24, and the only thing I have left over on the right hand side is that 12x. And then our very last step said that we were going to look for any multiplication or division to get rid of. So on the right-hand side, this says 12 times x. So in order to get rid of multiplication, we are going to divide by that 12 that's currently in front of that x. And whatever I do to one side, I have to do to the other side. So the 12 on the right-hand side cancels out, leaving us with just a plain x. On the left-hand side, 24 divided by 12 is 2. Now we still need to check our answer just like we've been doing all along. So I'm going to take that 2 that we're thinking is our x value and I'm going to plug it back into my equation to make sure that it works. So 7 minus 8 times 2, and we're hoping that equals 4 times 2 minus 17. Now we've got two sets of multiplication to take care of. So on the left-hand side, when I take this negative 8 times 2, I get negative 16. And on the right-hand side, 4 times 2 is 8. Minus 17. Now on the left-hand side, when I take 7 minus 16, I'm going to get negative 9. And on the right-hand side, when I take 8 minus 17, I'm going to get negative 9. So we have a matching set of numbers, which means that our x value is, in fact, 2. As we take a look at our next example, we're going to run through our steps again. So step number 1 says look for any distributive property that you're going to be able to take care of. So on the right-hand side, we've got that 2 in front of our set of parentheses. So we're going to take care of that distributive property by distributing that 2 into the parentheses. So we're not changing anything on the left-hand side right now. So we've got 5z minus 2, but we are adjusting the right-hand side. When I take 2 times 3z, we're going to get 6z. When I take 2 times negative 4, I'm going to get a negative 8. Now we move on to step 2. Step 2 says if we have variables on both sides, we're going to try to get them on the same side. Now I want to avoid having negative variables, so I'm going to move the smaller of the two variables. So I'm going to move this 5z. Now that's a positive 5z. So in order to get rid of something that's positive, we need to subtract it. So I'm going to subtract 5z on the left-hand side, and whatever I do to one side, I also have to do to the other side. So I need to subtract 5z from the 6z. So we'll cancel out that 5z and minus 5z on the left-hand side, leaving us with a negative 2. On the right-hand side, if we have 6 z's and we take away 5 of them, then we've only got 1 z left over. Now, it's not necessary for us to write the 1 in front of the z. I'm just going to leave it as a regular z. And then we have our minus 8. Step number 3 said look for any addition or subtraction to get rid of. So on the right-hand side, I see z minus 8. So to get rid of the minus 8, we're going to add 8 to both sides. On the right-hand side, the minus 8 and the plus 8 cancel each other out, leaving us with just a plain z. On the left-hand side, if I take negative 2 and add 8 to it, we should get 6 as our answer. Now, step number 4 says look for any multiplication or division to get rid of. There is no number in front of my z, so we don't have to worry about that one. The last thing that we need to do is check to see to make sure that this 6 works. So we take 5 times 6 minus 2, and we're going to hope that that equals 2 times 3 times 6 minus 4. So I'm going to start inside of the parentheses on the far right-hand side. So we'll have 2 times. Now, 3 times 6 is 18, and if I subtract 4 from 18, I get 14. On the left-hand side, I'm not going to change anything yet, but now I have 2 sets of multiplication to take care of. On the left-hand side, 5 times 6 is 30, but then we still have that minus 2. On the right-hand side, 2 times 14 is 28. And then on the left-hand side, 30 minus 2 is 28. So we get a matching set of numbers, which proves that our z answer is 6. As we look at our next example, we're going to start with step 1 again. Step 1 says look for any distributive property that you can get rid of. This problem doesn't have any distributive property, so we're going to move on to step number 2. Step number 2 says get all of your variables on the same side. So right now we've got that 5x on the left-hand side and that 2x on the right-hand side. In order to keep our variables positive, I'm going to move the 2x. Now this is a positive 2x, so to get rid of a positive 2x, I'm going to subtract 2x. And we need to subtract 2x from both sides. So on the right-hand side, the positive 2x and the negative 2x cancel each other out. On the left-hand side, when I take 5x minus 2x, that's going to give me 3x in there. I still have that 13, and then on the right-hand side, I still have that negative 8. Step number 3 says look for any addition or subtraction that you can get rid of. So right now, we've got this 13 in front of our 3x over here. So to get rid of this positive 13, we're going to have to subtract 13 from both sides of our equation. So on the left-hand side, we're just going to have our 3x left over. On the right-hand side, if we take negative 8 and subtract 13 more from it, we're going to get negative 21. Last step says that we're going to get rid of any multiplication or division. So right now we have 3 times x. So to get rid of the times 3, we're going to have to divide both sides by 3. So the left-hand side is going to be x equals, and then on the right-hand side, when I take negative 21 and divide by 3, we're going to get negative 7 as our answer. Now we need to check our answer, so I'm going to go back up to the original equation and plug in the negative 7. So 13 plus 5 times negative 7 equals 2 times negative 7 minus 8. Now you've got 2 sets of multiplication to take care of. So on the left-hand side, when I take 5 times negative 7, that's going to be negative 35. On the right-hand side, when I take 2 times negative 7, that's going to be negative 14. And then we still have that negative 8 over there. On the left-hand side, when I take 13 and add negative 35 to that, we get negative 22. And on the right-hand side, when I take negative 14 and subtract 8 more from that, we get negative 22. So because we have a matching set of numbers, that does confirm that my x value is negative 7. Now we've got one last example that we're going to take a look at, and we're going to run through our steps again. So step number 1 says look for any distributive property that you can take care of. So on the right-hand side of this equation, we have some distributive property with that 1/4 fraction in the front. Now I have to be extra careful when we distribute this 1/4 in because we're dealing with this fraction. So when I take 1/4 times 16, I'm going to take that 16 and put it over 1. So 1 times 16 on the top is 16, and then 4 times 1 on bottom is 4. Now we have that x attached to it. 16 divided by 4 leaves me with 4x, but now I also have to take this 1/4 and distribute it to the 60. I'm going to put the 60 over 1. When I take 1 times 60, we get 60. On bottom, when I take 4 times 1, we get 4, and 60 divided by 4 is 15. So by distributing that 1/4 in, we got rid of the fractions because that multiplied out nicely. Now we do have variables on both sides, and step number 2 says get rid of variables on both sides. We have 9x on the left-hand side and 4x on the right-hand side. To keep my x's positive, I'm going to subtract this 4x over to the left-hand side. So on the right-hand side, positive 4x and negative 4x cancel each other out. 9x minus 4x is 5x. I still have this minus 5, and this is equaling 15. Step number 3 says get rid of any addition or subtraction that you're able to. On the left-hand side, we've got this minus 5, so I'm going to add 5 to both sides. The negative 5 and the positive 5 cancel each other out, so we have 5x equals, and on the right-hand side, 15 plus 5 is 20. Last step says look for any multiplication or division. On the left-hand side, we have 5 times x, so to get rid of times 5, I'm going to divide both sides by 5. So the left-hand side is x equals, and on the right-hand side, 20 divided by 5 is 4. Now we do need to check our answer, so I'm going to take that 4 and plug it back into my original equation. So we've got 9 times 4 minus 5 equals 1/4 times 16 times 4 plus 60. Now I'm going to start inside of the parentheses on the right-hand side. So when I take 16 times 4, we're going to get 64 there. And if I add 60 more to that, we should get 124. On the left-hand side, I'm not going to change anything quite yet. We've got 2 sets of multiplication to deal with now. On the left-hand side, 9 times 4 is 36, but then we still have this minus 5 attached to it. Now when I multiply by this 1/4, I'm going to put this 124 over 1. Now on top, 1 times 124 is 124, and on bottom, 4 times 1 is 4. If I simplify down the left-hand side, 36 minus 5 is 31. And on the right-hand side, when I take 124 and divide it by 4, we get 31. So we have a matching set of numbers here, which confirms that our x value is 4. That's going to be it for this video. Thanks for watching.